Okay, let's quickly do this homework problem in my math lab. It says the matrix A given below corresponds to a system of linear equations. After the Gauss Jordan elimination is applied to A, you get B. Write the system of the linear equations corresponding to A, and then use B to give all solutions of the system of linear equations. I'm doing this because there are infinitely many solutions, and I want to explain it. So, first off, here is matrix A, and this corresponds to x1, x2, x3, and the equal sign. So 7, -3, -3, -1. 7, -3, -3, -1. -2, 1, 2, 4, -2, 1, 2, 4, right? That's the beginning matrix. Now, if we're going to solve this one, which I'm going to put it right over here, I have it ready to go, we need to find a 1, and then we need to pivot. So we'll normally try to find a 1 here, and then go down this way and see if we can get a 1 and pivot. So let's find a 1 where the 7 is. So I create a 7 by multiplying row 1 by 1/7. Then pivot on this 1 and make a 0 below. So multiply this by 2 and add down. 2 times row 1, add down to row 2, and replace. Okay, now I need to make this a 1. Multiply by 7. Row 2 by 7. And then make this a 0 above it. 3/7, and then add up, right? Multiply row 2 by 3/7, and then add up. Oops. Oh, sorry, wrong one. Multiply row 2, so multiply by 3/7. So add 3/7 times row 2, and then add it to row 1. You're adding up. There we go. So now this was x1, x2, and x3. Now how do I know that it's infinitely many solutions? Because I can't get a 1 in either of these. If I do, like for example, if I get a 1 here, then I would have to divide by 3. Well, then that creates 1/3. Watch. Multiply row 1 by 1/3. Now the 1 is here. Now I make a 0 here. But if I make a 0 here, this adds back down into here. It gets messy, right? So I'm going to step back. So this arrow steps me back 1 to where I was. The goal was just create a diagonal 1s, and now we can see what we have. x1, x2, and these are x3. So let's see how that corresponds with the matrix. I write it out. 1x1 plus 3x3 equals 11. 1x2 plus 8x3 equals 26. Now notice there's an x3 in both of them. So what that means is that we can choose a number for x3, and then we find x2 and x1. So there's an infinite number of solutions because we can't get a 1x3 in here. It's only 1x1, 1x2. So now what we do is we write the equation by moving these portions to the other side. x1 equals 11 minus, I subtract a 3x3 on both sides, right? And that brings it over here. I do this one also. 26 minus 8x3. So these are the two equations now. Choose any number you want for x3, then you get x1 and x2. That's what this is saying. When you do this and you don't have another row down here to get your x3 for a proper solution, then you go until you have diagonal 1s wherever you can get them. Maybe there would have been a 1 over here and a 1 over here. That's okay, but you try to get 1s wherever you can get them. And then once you have two ones and zeros above and below, then the third variable that's left is the kind of free range variable. So we go back to the solution. There are infinitely many solutions. x3 is any real number. So x1 was the 11 minus the 3x3, and x2 was the 26 plus the negative 8x3, right? So that's it.